So what we're going to do in this video is we're going to look at the average rate of change again, but we're going to take a peek at how the average rate of change changes over time. And so what I have a line drawn here that goes through this curve, and this curve is the equation x squared plus x minus 12. And what I want to do is look at how can I change this secant line and look at the average rate of change over different intervals a little bit more quickly rather than plugging it into the average rate of change formula, I guess. And so what I'm talking about is I'm going to try to find a way so that I can plug different values in and come up with a bunch of different average rate of changes along this curve. And eventually we're going to try to get it really, really close to a difference of 0 and see what the slope is at this point right here. So it's called the slope at a tangent line. But for now, we're just looking at the slope of this secant line that goes through 2 points on the curve. So let's dig a little deeper into this. This is, we're going to draw a curve, I guess. So I'll just kind of draw some random curve up here. So there we go, something like that. Okay. And let's kind of pick a couple points on this curve. So here, let's do this in pinkish. This will be x1, y1, x1, y1. And let's grab a new point. We'll do that up here. This will be x2, y2. So if we want to find this average rate of change, and it's kind of like we're finding the slope of this line that, and it's exactly that, we're finding the slope of this line that goes through these 2 points. But it's not, it's not the slope of this curve because the curve is curved, so there's a bunch of different slopes as we get from pink to blue. But like we talked about, in our average rate of change video, this is going to be, what we'll call it average rate of change. That's going to be the change in y over the change in x, which is y2 minus y1 over x2 minus x1. Okay, so this is kind of the building blocks of where we're going today. I'm going to change things up a little bit, though. I'm going to call this, instead of x1, y1, I don't want to call it that. I want to call it x1, f of x1. So we're going to use function notation here instead of, x and y. And same thing with the blue one. It's going to be x2 and then f of x2. And so really our slope then, our average rate of change, the slope of this secant line, is going to be f of x2 minus f of x1. And that's a 1 there, 1, all over x2 minus x1. Okay, but of course I'm going to switch things up a little bit here. Let's grab the green pen. And so I'm going to kind of draw this little triangle here, dotted. And what I want to do is I want to call this length I move over in the x direction, we're going to call that h. And so what I'm looking for is I want to be able to find something that's going to make it so that if I just pick an h value and a starting point, I can find the average rate of change if I get those two things. I don't need 2 points. I need an initial point and then just how far over I want to go. So that's going to change things down here. Instead of x2 minus x1, that's just h. So really, keep in mind, this is really just the slope. We're still, slope starts with an s, I guess. This is still just the slope of this secant line that goes through these 2 points. It's the average rate of change. And so we're doing the y2 minus y1 over x2 minus x1, but we've done some substitution here. And so what I want to do next is, like, let's look at this h thing here. This is, we started at x1 and we ended at x2. So if I say, let's do this in pink. Let's say I said x1 plus h. What does that get me? So if I go x1 plus h, that's going to get me to x2. So I know that x2 is this stuff right here. So what I'm going to do is where I see an x2, I'm going to replace that with x1 plus h. So we're really transforming this a bunch, but we're going somewhere with it. So this is going to be f of x1 plus h minus f of x1 all over h. So if you notice here, sorry about my unstraight line, if you notice we have an expression now for the slope, and that is you take the function plus h minus the function all over h. And so all we need is an initial x value and some h that we're going to move over. We don't need this second point because we kind of did some substitution to get rid of it. So really, I'm just going to, instead of calling it x1, all I care about is that I have an x value. So I don't need this 1 there and that 1 there. So what this is called, it's really kind of fancy way of saying slope, is called the difference quotient. So the difference quotient. So when you see difference quotient or average rate of change, you should be thinking slope all the time. And so the difference quotient is this expression right here. And what this is giving you is the slope of this secant line that passes through these 2 points. So let's kind of look at an application here. Let's go back to this graph. This is x squared plus x minus 12. And I'm just going to start at -4. And I'm going to change my h by, you know, whatever I want to change it by. So if, let's say f of x is x squared plus x minus 12. And I'm going to say, well, here's what I want to do. We're going to say this is my f of x, and I want to show you how to use it with this difference quotient expression here. So let's do so. When it says f of x plus h, we're just moving over x plus h, so it's going to be everywhere I see an x here, I'm going to put x plus h. So it would be x plus h squared plus x plus h minus 12. And then, so I've got my f of x plus h, and then I'm going to do minus f of x, so minus x squared plus x minus 12. And remember, this is minus f of x, so we're subtracting the whole expression. Maybe it'd be more clear if I put this whole first thing in parentheses as well. So this is f of x plus h, this is f of x. And then I'm going to do this all over a straight line, all over h. So when I do this, I'm going to kind of bring it, well, I'll try to write as small as I can. So I need to do x plus h squared. And so x plus h squared ends up being x squared plus 2xh plus h squared plus x plus h minus 12 minus x squared minus x plus 12. So all I did there was kind of distribute this negative sign, so it changed the sign of everything in there. And then this is once again all over h. Oops, h. And so let's look at this. We can start canceling some stuff out. I see an x squared and a minus x squared, so those cancel out. I see a plus x and a minus x, and I see a minus 12 and a plus 12. So everything here gets canceled out, and what's left is 2xh plus h squared plus h all over h. So you notice everything has an h in it, so you can cancel out an h out of everything. And we're left with, I'll get something a little darker than green so we can see it. We're left with 2x plus h and then plus 1 because of this h over h is just 1. So this is, using the difference quotient, we get this expression, this 2x plus h plus 1, and this is a way to find the slope using just a given point or a given x value and how far over you want to move it. So let's say we want to start where x is -4, like I showed on that graph there. So let me grab my pen. X equals -4. And let's say I just want to move over 3 units or something like that. So let's plug it in, and we'll show you on the graph what I'm talking about. So using the difference quotient, it's going to be 2 times -4 plus 3 plus 1. And so we get -8 plus 3 plus 1, so we get -4 altogether. And so what this gives us is the average rate of change as we go from x equaling -4 over to x equaling -1. So let's look at the graph and see what that looks like here. Let me pull that up for us. So as we go from -4 to -1, oops, I lost it there. Where are we? There we go. So the y value changes by a rate of -12, and the x value changes by a rate of +3. So -12 divided by 3, that's going to be the slope of our line. That would be -4. So the average rate of change, or the slope of this secant line, is -3. So what you can do is find a quick, easy way. So if we move this line so that these points are a lot closer, you can find what the slope of this line is that goes through -4, and that'll be a little bit further down the road. But this is just a way to find an expression using the difference quotient, and using this expression right here. This is kind of the key expression, my beautiful star, that gets us any rate of change, any slope of any secant line, where you can just pick a starting value and then just how far over you want to move. So that is difference quotient.